Hi everyone, welcome back to another Creative Coders Toolkit video where today we're going to be tackling a fairly simple abstraction that is something that's actually built into Max MSP, and it's also available in Pure Data through the Cyclone external, but it's a really good exercise to sort of try to figure out how to program it yourself, because it's a great way of learning how to build these kind of mathematical expressions in a way where you can take it apart, understand what it's doing, and then apply that to future math problems that you might come across. So the specific abstraction that we're building today is usually referred to as scale. I've also heard it called map. Today, we're going to be building three different kinds, ranging from the simplest all the way to the version that I'm pretty certain is able to be flexible for all ranges of numbers that could go into it. Let's start with some theory. So when building this map scale object, version 1 is going to be the most basic form. So let's say you've got a 7-bit number, also known as 0 to 127. This is commonly used for things like MIDI. And then let's say that you want to turn this MIDI range into, let's say, an 8-bit number. So like 0 to 255. And this is a number range used for all kinds of things like RGB, tons of other stuff. This is by far the simplest version of scaling or mapping, because what you can do is just take your input, times it by 2, and that gets you your output. Now, it's not perfect because 127 times 2 does not equal 255, but it gets you pretty darn close. Like, this is, good enough. So let's take a look at what this might look like in Pure Data. So if we open up our application here, get a new sketch going. So we're going to build out our abstraction. So we are going to have an inlet. We are also going to need an outlet. And in the middle, we just need to multiply everything by 2. This is the entire abstraction. You can also just make a multiplication box inside of the sketch that you want to build, but for the sake of creating the abstraction, we can go through here. And I'm going to, normally in Max and in Cyclone, this object is called scale. So to make sure that we don't have any collisions, I'm just going to name mine map. And this will be map 1 for the first version of this that we're building. So if we close that out, launch a new sketch, and we'll actually test it. So let's say I have 100 going in, and then map 1, and then let's see what we get out. Boom, 200. Okay, so there's our first map. Let's try building a more complicated map now. So difficulty level 2. So let's say we want to actually be able to account for other changes in values. Let's say that we want to have something range from 0 to 100 is our input. And let's say that the numbers that we want to get out are 50 to 350. Maybe this is a value that we need for, an Arduino project, or, this is the range of parameter that we want for some kind of instrument, some kind of volume level, just anything. Like, this scale map object is so versatile for so many different kinds of things. So in this instance, we do actually need to build out some kind of logic that can control the input values being turned into the output values. So what we need first is the ratio. and that'll get us the multiplication value between the input and the output. The ratio is going to be the fractional difference between the two different ranges with output on top and input on bottom. So what that would look like is 350 minus 50 over 100 minus 0. So that's going to be 300 over 100. That's the difference of the ranges. And so our ratio is going to be 3. Now for this example, the second thing that we need is what's called the offset. And that's going to be the number that gets the input range into the correct placement of the output range. The ratio is how much it needs to be multiplied by, and then the offset is going to be a plus or a minus to get it just to the right number. So just looking at this, you can tell that the number is 50. These calculations get a little bit trickier as time goes on, and this is just the medium version. We'll get to the much, much harder version. But in this case, it is just 50 minus 0. And that gets us this 50 value. So 3 is the ratio and 50 is the offset. Let's go take a look at pure data and see how we can actually build this. So back in pure data, we're going to open up a new sketch. And this is where we're going to build this second difficulty of this map function. So we're going to start with an inlet. We're going to eventually get to an outlet, and we've got some math to do on the inside here. And so what we need to do is we need to have 4 values for this abstraction to take. So we're going to save this as, and this will be, we'll call this map 2. So if we open up a new sketch here, minimize this guy, we're going to take a look at what kind of input parameters we're expecting to be able to get this object to work the way that we want it. So specifically what we're looking at is we're going to call map2, and then we're going to give it 4 values. In this case, we're looking at 0, 100, 50, and 350. So when we do successfully build the inside of this, these are the numbers that we're testing with. So now let's build the logic inside of this object. When building this mathematical function, we're going to want to make sure that we do all of these steps in the right order, since we have subtraction and division, and then at the end, another addition or subtraction. So let's start with our 4 parameters. And in this case, these are going to be $, and then 1 is the first parameter. $2 is our second parameter. $3 and $4. You can make as many of these objects as you want, and they will automatically fill with whatever your creation parameters are. So right now this is 0, right now this is 100, right now this is 50, and this is 350. Let's cut back to our notes and take another look at the steps that we need to take and in what order, and we can try building this out. Okay, so step by step again, to get the ratio, what we'll want is to do, we've got $4 minus $3 over $2, $1, and that gets us one number over another number, and then there's our ratio. So let's see if we can lay this out in pure data in a way that makes sense and in a way that gets us our answer in the correct order. In this instance, we'll want to make sure that we calculate the denominator of this fraction first, fill in that value, And then when we send the numerator in through the hot end, that is what will prompt the calculation to go through. So let's grab some mathematical objects. We've got our division here. And then we also need a couple of subtraction objects. Okay, we're going to build the logic that handles what order these go in towards the end, because we want to make sure that we kick these off all in the correct order, but we'll build that out later. So what we want is for our first value to go into the cold side of this subtraction object, and then the second parameter to go into the hot end. That is what's going to actually make that number come out of the bottom, and then it'll fill the cold end of the division object. And then we've got third parameter into the cold end, fourth parameter into the hot end, and that will push this through. And then that is what will give us the outlet of here is our ratio number. So let's hang on to that for now. So now let's think about what gets us our offset value. And in this second example, it's going to just be our third parameter minus our first parameter. So let's see if we can get that into pure data. Okay, so we're going to need one more subtraction object. We can put it over here. That's going to be subtraction. So we need our first value, cold end, and we'll do third value in the hot end, and that'll get us the value out of here is going to be our offset value. And this is going to be fine because this is the order that we want that to happen in. So in this instance, that is totally usable. So now let's think about when we have values coming in through the inlet, what do we want to happen to them and in what order? So first, we want them to get multiplied by our ratio value, and then we want to add our offset value. So let's move these down so we've got a little bit of room. Okay, so here is our ratio. We'll fill the cold side of our multiplication. Here is our offset. Same deal, cold end here. We go from the ratio to the offset and then to the outlet. Now we just need to think about how do we build this in a way that makes sure that all of these operations happen at the right time and in the right order. So we're going to build what's called a trigger object. Its shorthand is just T, and then the other parameters that you build are just bangs. And so you can put as many bangs as you want in this, and what it will do is it sends the furthest right bang out first and then moves to the left. So our very first bang is we're going to push that first value. Second bang is going to push the second. And now let's think about the rest of the order that we want here. This second bang can also be used to kick this third value. And then last but not least, we're going to do this one. So for right now, this is doing everything in the order that we want it to happen, with the right side happening first, moving towards the left. The last thing we need now is for our input number to get sent through this far left side last. And so one way that we can do that is by just filling this float box, this number box, with the value of our inlet through the cold side. And then at the very end, we're going to kick that value through because we'll know that all of this calculation has been done. And so then at the very end, this gets kicked through here, gets multiplied by our ratio, has the offset added, and then it sends it to the outlet. So now we'll save that. Here is our second map abstraction, and let's see what happens when we try to use it. So we can close that guy. We'll delete that one. So we've got map 2, 0 to 100, 50 to 350. Number box on the output, and we can put a number box on the input. And then let's just see what kind of values we get. Okay, so the reason that this didn't work is because I totally forgot to wire up our trigger object. So now if I save this guy and we come back here, we can see input of 0 gives an output of 50. And if we run our number value all the way up to 100, we've got 350. Now, the nice thing about these scale or map objects is that if you go past, it keeps following the same ratio and offset values. It's not capped at either end, and it'll just follow the same formula. If you want it to not do that, then you have to clip either end. And that's another thing that you can add later on. It's just an extra piece of logic that keeps it from going past the bounds that you've told it you want it to go. Usually, though, when you build something like a map or a scale, you want it to be able to take values outside of your initial range and just keep going with it. It just totally depends on the application that you're building for. Now, the main downside of this second map function that we just built is that it is completely limited to that first value being 0. Your input values all have to start at 0 and then go to another number. That's the only way that this function that we built will continue to work. If you want to have a much more flexible map or scale object, for example, one that's able to handle things like, a range of -10 to 100, 50 to 350, this is the type of scaling that so far we have not built the logic to handle. So let's go back to our notes and see if we can figure out what we need to do in order to fix the offset. The ratio is the same calculation and that will still work, but we need a smarter offset to be able to handle this type of scenario. Okay, so let's fix our calculation for offset to make sure that we have the ability to handle different kinds of problems. So for our third map function, let's say that we want to build something smart enough to be able to handle something like -50 to 150, 100. Let's make the ratio a little simple. Let's have this go to 500. So for the ratio, what we end up with is 500 minus 100 over 150 minus -50. So we get is 400 over 200. So a ratio of 2. That's nice and easy, but what we need is to make sure that our offset is flexible enough to handle this type of scenario. So we need to make sure that our offset is actually being affected by the ratio that we calculated. Let's start by trying to do some of these values by hand and see if we can start to notice a pattern with it. So if we have an input value of -50, let's see what we need to do in order to end up at our value of 100. So if our input is -50 and we want to get to 100, first we know that our ratio is going to hit. So -50 is going to get multiplied by 2, and we're going to get -100. Now, in order to get from negative 100 to 100, we're going to need to add 200. And that'll get us to 100. Let's see if that also works on the other end. So we've got an input of 150, and we want to get to 500. So we know that our input is going to get multiplied by the ratio. So then that is 300. And then we need to add 200 to get to our last parameter of 500. So what do we need to do in terms of this algorithm in order to make sure that that happens always? Technically, you can build this from either set of input or output values. That's just sort of the way that algebra works when you start thinking about like slope and, y equals mx plus b. Both sets of numbers are going to work. Sometimes it's easier to think of in terms of your initial input values. So let's see if we can build the algorithm from that way. So our offset is going to be equal to our third value minus our first value times our ratio. And that's going to get us our offset. So with the input example, this is going to look like 100 minus first value. It's going to be negative 50 times our ratio, which is 100 minus negative 100, which is going to equal 200. And that's the same value that we calculated before. So here is our algorithm in order to get this value regardless of what our input value is. It can, in this instance, it can be a value that's not 0, and it'll still scale correctly because we're using the ratio to help calculate this difference. So let's cut back to pure data and see if we can build a version of this abstraction that's a little bit cleverer. So let's grab a new sketch here. Same deal. We're going to end up with an inlet and an outlet. Functionally, a lot of this is going to end up looking pretty much the same. Because there's nothing wrong with our ratio calculation. We just need to fix the offset a little bit. So we've got two subtraction functions. We've got a division in order to get our ratio value. Let's just build this out one more time. And so now the output from here is going to be our ratio value. And we're going to need that value with our new algorithm because we need to affect one of our previous values. Let's take another look at our notes and see what order the next step needs to happen in. So that offset value is going to be our third value minus our first value times the ratio. So let's see if we can lay this out in a way where we're going to still get the correct value in the correct order. So we've got a multiplication happening here between our first value there and this ratio value here. To make sure that we get this to go in the correct order, I'm going to go ahead and add another version of this third parameter just to make sure that we could potentially reuse this one, but it's way more likely because we need this ratio value that this is going to happen out of the order that we need it to. So I'm going to create another one of these to make sure that we have everything happening in the correct order. So here is the second half of our offset calculation. And we need one more subtraction. So we'll fill the cold end of the subtraction with this value. And then we know that it's going to be this value that this gets subtracted by. So now let's see if we can build out our logic one more time. We know that we are going to multiply our input value by the ratio. And then we're going to add that offset value. So same deal, we're going to fill a number box with our inlet. It's going to get multiplied by the ratio, add the offset to it, and then send it out. So now all we have to do is handle the order that all of these things need to happen in. So let's take another trigger box. I think we can do this in 5 bangs. First things first, let's make sure that our inlet is set up correctly. So first bang, let's make some more room for ourselves. Here we go. So first bang is going to push that through. Second bang for this one. We can have this happen at the same time as that. Third is going to be this fourth value in. Then we're going to send this value in because so our ratio is being used to send this through over to here. Then this is going to come through and get our offset value into here. And then last but not least, this very last bang is going to push our inlet value through, and then the calculation is going to happen. So now we can save this one. We'll call this map 3. And if we go to actually build it here, here we go. We'll get a number box on the bottom here. New number box up top. So if we have 100 on the input, we've got 350 on the out. So it looks like our calculation is working correctly. So specifically for this third map function, this might seem like an awful mess to make just to get what should be a fairly simple calculation done. You might also be thinking to yourself, gee, couldn't you just build a couple of expression boxes and send your information through those? And absolutely, yes, you can. So using this same algorithm, let's build another version of this using some expression boxes and see if we can clean up some of this clutter. So we're going to grab a new sketch. Same deal. We're going to have an inlet. We're going to have an outlet. And we're going to have a couple of expressions that handle the math that we're sending through here. So EXPR for expression. You may be tempted to try to build this entire calculation inside of a single expression box, but remember, our offset value needs the ratio value. So we're not going to be able to build this all out in one because we're going to have to reuse that ratio value in another spot. So first things first, we can get our $4 minus $3 divided by $2 minus $1. All right, here is our ratio value. So far, so good. Let's put another expression value. So now using that ratio, we can use it to finish our offset value. So we have $3 minus, and then it's going to be $F1. That is how you tell expression boxes to use the first inlet, and you're also telling it that it's going to be a float value. You could do $I1 if you know it's going to be an integer. In this case, we might end up with a ratio of fractions, decimals. Might not be a pretty number, so you want to make sure that you have that be a float to handle when it's not a perfect integer number. And then that's going to be multiplied by $1. So there's our offset value. One thing you want to be mindful of is that you still want your calculation to happen before you send your input value through. So we're still going to build a much simplified trigger system. We have our float input number there. That's going to be making this trigger happen. First things first, we send this through here. And then we do still want our multiplication with that ratio to happen. And then we want our offset to be applied. And then value goes out. And then last but not least, it sends our inlet value through. And we'll call this guy map4. So right now, there is still one more thing that's going to not work properly with this. And I'm going to show you what that is. So we can close this out, close out map3, and we've just got our test sketch here. We can lose these. So if I build a map4, and let's do some crazy numbers, definitely want to make sure that we do not end up with a clean ratio. What I'm trying to test for now is any time that we end up with a ratio that is not just an integer value. Clearly, this is not behaving as intended. If we take a look inside of our abstraction object here, you can see that this is an actual instance with our parameters on it. And one thing that we can do here is pop into edit mode, and let's get a console log of what's happening here. And then if we move this number back, what we're seeing is that the calculation happening for the ratio is incorrect. What we should be getting is, so the difference between these two is 100, difference between these two is 230. So our ratio should be 100 over 230, but what's happening is that it's taking the floor of that value because it's not able to actually calculate it as a float, and it's just showing it as 0. So one thing that we need to do here is actually make sure that this expression is handling these decimal float values. And the way that you get the expression to cast as a float is you add float in front of one of these parameters. And now if we save this and move this around again, what we can see printed is the correct ratio value. And then what we see is that our input is actually being correctly mapped to the output value. So there are 4 ways to build a map or scale abstraction object in a couple of different levels of difficulty. If you can find an example of that very last one not being flexible enough to handle a particular use case, please let me know. I would love to take it back to the drawing board and see if there's some way that we can design that algorithm in a way that handles all kinds of input values. I will admit I didn't test every single possible type of input value, so it is possible that there are some that this algorithm is not able to handle. Please do let me know if you find an example that it isn't able to. And I hope that you learned something about using expressions and also learn something about being able to build out mathematical equations in a way that they all happen in order, and a little bit about how to call those parameters and use them inside of your abstractions. That'll be it for this video. Please leave a comment if you have any questions, or please feel free to email me at creativecoderstoolkit@gmail.com. Have a great day.